So as you saw from the title description of this video, I'm adding another power supply to my collection. So why would I be doing that? Well, I've got my two Unit T's 0 to 30 volt power supplies that are still working fine. But as I've been fixing a lot of TVs lately, I keep on finding myself having the same problem over and over again. That is, I just don't have enough voltage to check many LEDs that are in series. Sure, I can take my two current power supplies, run them in series and get 60 volts. But even at 60 volts, sometimes that isn't enough for some of these TVs with how many LEDs they have in series. Plus, if these are tied together in series, well, now these are tied up, and if I need a 12 volt rail, well, I'm out of luck. I'm out of power supply. So I'm just going to add one high voltage power supply in the mix here. This is up to 120 volts at 1 amp, so that will be perfect for running many LEDs in series. Now, theoretically, I'm hoping that if it's set up good, I should be able to set the current to, set the current to 100 milliamps, turn the voltage all the way up, hook up a set of series LEDs, and it should bring the voltage down while limiting the current, of course. And it should do that quick enough without blowing the LEDs before the voltage comes down to where the voltage needs to be to meet that set milliamps. This is a linear power supply, so it's got a little bit of heft to it. It has an actual transformer on the line voltage, 60 hertz. Got nothing against switching power supplies. It's just I kind of like good old clunky, beefy, linear power supplies. So to start, I'll start with the banana plugs. I'm noticing, they're a little different than usual, and there's probably a good reason for that. Like typical power supplies, you got your banana plugs, you can spin this out, you got your hole to shove your wire into. But now, since this is high enough voltage to hurt you, they can take the shielded, like meter leads, banana plugs, whereas your traditional power supply, it can't. The shielding gets in the way. And now, since this power supply doesn't have a banana plug you can just spin out and jab a wire into, I think that's why they give you these terminals down here to hardwire just bare wire to. I think next I'm going to check out the user interface. So I spent a minute messing around with the user interface. First thing I noticed is the display looks great. I mean, it's got good contrast, lights up nice and green, and it's actually really easy to see. I'm not surprised it's as good as it is. This is a budget power supply we're talking about here. It's like $130 or something like that. So my expectations aren't super high for a low dollar power supply. This is actually a better display than I think what they have on the 0 to 30 volt model. Speaking of where I got this from, I bought this off of eBay from the Tekpower distributor, one of their authorized sellers on eBay. And it was $140, I think. But after I bought it, I started looking at Circuit Specialist's website, and I don't know, probably should have ordered a power supply from them. They get a lot of power supplies to choose from too for really good prices. Circuit Specialist also has the schematics for their rebranded version of this one too, so that was kind of nice to see schematics. And yeah, interesting. This transformer has a lot of secondary taps on it. Anyways, you can download this from Circuit Specialist. So I was playing around with the user interface, like I said, and I noticed when you first turn it on, I've already set this to 100 milliamps before I shut it off, and it remembered that it's at 100 milliamps, which is great. But when you first power it up, it's in the constant voltage mode, so it ignores what I set the amperage to, and it goes balls to the wall at 1 amp. It's pretty accurate too. It's not too bad, comparing a Chinese power supply to a Chinese meter. So what do you expect? But when if for my use, I'm going to need to be using the constant current mode. So I'll have to turn it on, click this, and now it's going to use the set current, so it should be limited to 100 milliamps. And there it is. It's a little bit of wander on this display, but according to my meter, it's pretty dang tight on. Let me see if I can knock it down a notch there. Yeah, so that seems okay so far. I just have to remember that when I turn it on, I gotta click the constant current. Next thing I noticed is the dial for controlling the voltage. It seems to be a multi-churn potentiometer. It has a stop to it when you get to the end. It's not an encoder. So there it hits the end at 125.5 volts. Give her a bunch of churns to the other way, and we're at her 0. I like it. You can get accurate with it. And yeah, 5 volts. Let's see how accurate we are at 5 volts. Should we? Okay, so negative there. Let's do this. Let's see if there's any big old surges in power. I'm going to use the max mode on my meter, so it will hold any spikes that it sees. Heh, nothing. That was awesome. I went right to 5. Again, I'm surprised. Let me try that again. I'm expecting to shoot up to some ridiculous number. It takes a while to die down too when you hit the power button. That's kind of a lot of capacitors in there. No, again, it didn't shoot up. Let's try a different voltage. Let's try 12. Oh, of course I gotta take my meter back out of. Yeah, I like this voltage adjust better than their 0 to 30 volt model. A lot less dinking around. You want the voltage up, you just turn it up. Okay, let's get it to 12 volts. And again, pretty good accuracy. Power it down. I'm going to use the max mode again so it stores any voltage spikes. Overload. That's interesting. Let's try that again. This time I'm not going to use the max. See if we can catch it doing something it's not supposed to do. I probably should have a good oscilloscope for this, but I don't. I'm going to use the max mode one more time. I didn't get a spike that time. Let's try it in constant current mode. It's going to reset anyways once it powers down, but what the heck. Yeah. Seems alright. So to show the current control on this meter, again, when you first turn it on, it defaults to 1 amp. It ignores the current set. So we put it in constant current mode. And now for every click of the button, you get 10 milliamps. So there's approximately 10, 20, 30, 40, 50, and it does the increments all the way up to 1 full amp. And you can just hold the button down here and it will run quicker through the settings. And there's the 1 amp. So to go over some of the differences between the 30 volt model and the 120 volt model, here with the 30 volt model we have an LED display, rotary encoders for adjustments, and then the posts here for the banana plugs are the more standard banana plug jack you'd find on a 30 volt power supply, except these don't have holes in them, which is unfortunate, but you can wrap a wire around here and tighten it up. Whereas the 120 volt model has an LCD backlit display, and then buttons up and down for adjusting current, and a approximately 7 or 8 churn potentiometer for adjusting the voltage. And then it has the sleeved style banana plugs with the extra terminals hidden under this cover here. To make adjustments on the 30 volt model, you push in and then you can select which digit you want to change. So let's say we want 5 volts. We just go ahead and select that digit, go up to 5, wait a few seconds, it stops flashing and enters it in. Same with the current, you click in first, and then at this point you can select the digit you want to change. It can get pretty accurate if you don't mind you know, a little bit more putzing around. And it does roll over too. And then again, if you just select it, wait, it stops flashing, it's now entered. On the 120 volt model, to make adjustments, first you have to make sure in constant current mode. It does not default to constant current. So when you first power it up, it is going to go at its full 1 amp. So you have to turn it on, select constant current, make sure this light is on, and then for every button push you're adding or subtracting 10 milliamps. And then for the voltage adjust, it's just a straight up potentiometer, 7 or 8 turn pot. So you just turn it up for up and down for down. Here's just a quick overview of the inside. So we start at the AC input socket here, where there is a 4 amp fuse, and there's actually a spare 4 amp fuse in here also. So it comes in and it does go through a mechanical switch. So when this is off, it's completely off, although it does have a memory function for the current. So here's the linear transformer. Here we're at the heatsink, where on the heatsink there's a actual mechanical style temperature switch, which on the back label here, I believe it says it switches at 50 degrees. It says that automatically comes on. The fan hasn't come on yet for me yet. I haven't had it hot enough, so I'm not sure how loud or what the fan sounds like. But it's just our old-fashioned mechanical style switch. You can actually see it. Power coming out of the board here. It runs through the switch into the fan. Anyway, so here we have the transformer, all the taps on the secondary, the transformer coming to the board here. There is a socket, or a clip style socket soldered to the board, but they didn't use it. They just soldered directly to the pins. A little bizarre. You can see this is a snap-in style plug here. So on the heatsink we have bridge rectifier here, and we have 4 large power transistors up against the heatsink there. So there's some large filtering caps. Here in the middle we have what I call just the brain board. I think this is in control of, I suppose, the voltage and current settings. Front panel at the top we have the display board, a button board below that, and then the output jack banana plug board down below. I did end up changing this capacitor right here. I'll go more into that later. And finally, here's the multi-turn potentiometer for the voltage adjust. Now the insides between the two are also very different. They really don't share anything in common. All the boards are different. Of course, the transformer is different, and even the sheet metal is different. Heat sinks are different. It's honestly like they came from 2 different designers or 2 different factories. There's not much at all in common between these two besides the color beige and the name on the front. So I ran into an annoying problem. Well, first of all, the current buttons, for every click it's 10 milliamps, which is fine. Right now I have it, so all the way down is 0. First click up is 10 milliamps. So right now this LED I'm running is limited to 10 milliamps, which is fine. Every 10 milliamp step is acceptable. Now, right now it's working right. It's in constant current mode. So since I have it limited to 10 milliamps, it's never going to allow the voltage to go higher to exceed the 10 milliamps. This is a native 12 volt LED. It's got a built-in dropper resistor. That's why it's able to handle, 30 volts. So I'll just go ahead and crank this up, and the voltage kind of settles out, but it never really goes over the 10 milliamps, which is what it's supposed to do. I told it to stop at 10 milliamps. But now, as you can see, it's working. Got a lit LED here. If I disconnect it, reconnect it, it just blew out the LED. It's not fast enough to adjust it back down in time before the LED blows out, and that's because there is a capacitor after the current regulation. So that capacitor is fully discharging into whatever it is you're working on. and I believe the culprit is there is a 100 microfarad capacitor on this output jack, you know, the banana plug board here, and that's probably the guy responsible for sending that burst to exceed the current limit. So I went ahead and removed that 100 microfarad capacitor on the banana plug board. I'm not sure how it's going to react. I'm not sure what side effects it's going to have without that. Maybe it will fluctuate more or oscillate, or, well, let's find out. So right now, well, actually it's already acting kind of funny. It's sitting at 1 volt with the knob turned all the way down, so it's kind of, it almost like it needs that tiny bit of load leakage from this electrolytic capacitor to drag it down to 0. Well, let's just see what happens when we crank it up. So again, I have it set 1 click up, 10 milliamps max. It should never go over 10 milliamps. It's in constant current mode. I'm going to crank the voltage up and see what happens. Well, okay, so it's about the same as before. It should stop right around the 30s. I'm just going to crank her up. It's at max right now. And yeah, see if I can get the glare off of there. Okay, so we're at the 10 milliamps. Let's see what happens if I open it. See there, it's jumped up to 130 volts, but will it be quick enough? Hey, look at that. It didn't blow out the LED. There's no more lag. Oh, that's great. All right, so maybe that's a worthwhile modification. I'll have to see if there's any side effects. So just for shits and giggles, here is a 1 microfarad, 350 volt capacitor, and when I connect it to the output, it drags that 1.3 voltage down to 0. So I kind of like that. I'm gonna see. Let's see if I crank up the voltage. I should still be in constant current mode. Yes, I am. So what would happen if I now get a high voltage on there? Excuse my reach here while I get this adjusted. I'm going to see if there's enough charge in that cap to blow this, and it didn't. No. Okay, let's just go a little bit higher. I'm just going to go up to max. Okay, so we're at 120 volts charged up in this capacitor. Let's see if it blows it. No, and it didn't. Good. So you know what? Maybe that's the ticket. Maybe a 1 microfarad cap is a good place to meet in the middle. It's enough to make the voltage read 0, but not so high that it causes that amperage delay lag. So now I'm going to put this through some practical use here. So I'm going to start with just a single LED, and right now I'm going to start with 10 milliamps. Nope, I'm above 10 milliamps. All right, 10 milliamps. The voltage shouldn't matter because it should pull the voltage down to hit once it reaches the 10 milliamps, it will hold the voltage there. So let's go ahead and probe this LED. And we're at 2.5 volts at 10 milliamps. Now this is probably a lot higher current rating LED, so let's knock it up a couple notches. We'll jump up to 50 milliamps. So at 50 milliamps, we're at 2.7 volts. This might be a 3 volt LED, so let's go even higher with the current. We'll go up to 100 milliamps and see what the voltage is sitting at. Okay, so 2.8. Let's hit 3 volts and see how much current we draw. All right, so we know this LED is 180 milliamps at 3 volts. Again, the voltage isn't important, so we could even start at 35 volts, and there we go. See, it pulls it down to 3 volts again. Now, even a better test would be a series strip of LEDs. This is out of an edge-lit TV. Now, I don't know too much about this strip. I don't know if they're all in series. They probably are. I'm going to need a lot of voltage to light this thing up. I don't know how much voltage, and I don't know if the strip works. So this is a good use for this. So to start with, I believe I'm still at my 10 milliamps. Yeah, no, let's go back down to 10, a little safer. Yeah, we'll even do 30 milliamps. Okay, so I'm gonna go ahead and crank the voltage all the way up. I think I'm gonna need it for this LED. And let's probe this strip. Okay, so at 30 milliamps, I need 116 volts. Let's see how much power I need at 50 milliamps. I need 122 volts to drive these LEDs at 50 milliamps. And I do know that, well, all these LEDs are good, so that's a good test for this. Now I'm actually exceeding the voltage. I will not be able to go higher. Let me just see what the limit is for this particular strip. Yeah, it looks like it's maxing out at 126 volts. The voltage is all the way up. And the highest I can go is 67 milliamps, 65 milliamps. But this is a good example on why I picked out this power supply, because it does control the current at a high voltage, at 120 volts. There's not a lot of power supplies to choose from at this voltage range, but there is a ton of power supplies. The market's flooded at the 30 volt range. You have a lot to choose from at the 30 volt range, and a pretty good selection even at 60 volts too. But once you start getting up over 100 volts, there is not a lot to choose from.